Before starting into the bread and butter methods of the core API, I wanted to give a quick explanation of something I've already been using without explanation, and will continue using throughout the rest of the course: Lambda expressions, also known as anonymous functions. These can sometimes be a point of confusion for those who have never used them. Feel free to skip to the next section if you are already familiar with them. Now, as I said, you've already seen me use these functions. For example, in our word counts flat map method, line goes to line, split on space. That's a Lambda expression. To understand how this works, we'll start with what should be the most recognizable form: the use of named methods. Here, we simply define a method which takes an integer value and returns that value incremented by 1. That method has a name, add1, so that it can be easily referenced in other portions of the code. So, we'll take a list of integers and take each item and pass it into the add1 method so that it can be incremented. Then, we yield that iteration as this new list of incremented integers. Simple enough. Most developers write code like this every day. So, let's see how this can be rewritten as a Lambda expression. Using the same add1 method and same starting list, we can accomplish the same transformation using list's map method. Here, map is the same as our for comprehension earlier, taking each integer in the list and mapping it through add1, resulting in the same output. But Lambda expressions allow for the code to be cleaned up even further. Instead of having to delegate the mapping to our add1 method, we can inline the method directly and still have the same result. Now, let's take this concise Lambda expression and use it to gain a step-by-step understanding of Lambda mechanics in comparison to the original named version. We can equate everything on the left side of the Lambda expression's arrow as a parameter list for the function, the same as a method's parameter list. So, our Lambda and add1's parameter lists are semantically equivalent. Then, everything on the right side of the Lambda's arrow is equivalent to a method's code block. That's it. That is all Lambda expressions are: a simplified view of a functional code block. How it's actually used depends on the method that accepts it as a parameter. In our case, map simply iterates through the list and applies the Lambda, placing each Lambda's execution result in a new list to be returned at the end of the iteration. Just as we had manually iterated through the list and called our named function against each item. One final note: as we saw earlier, Scala has the ability to have multi-line lambdas through the use of brackets, but Python only allows single-line lambdas. So, any Python code that requires more than one line will need to be put into a named method, and the lambda would just execute that method.